In this video, we're going to talk about properties of exponents. There are a number of them, but we're going to go through with them one at a time and do some examples for each one. So we have the product property, the power property, product to a power property, quotient property, zero exponent property, quotient to a power property, properties of negative exponents, and quotient to a negative exponent. All these properties are useful when we need to simplify expressions involving exponents. So let's take a look at these. So let's get started on the first property. The first property is the product property. So we have here, if a is a real number and m and n are integers, numbers like 1, 2, 3, 4, 5, 6, the counting numbers, or 0, or the negative counting numbers, those are integers, then we have this property. Right, so it says that if we're multiplying a to the m times a to the n, that's the same as a to the m plus n. Multiplying is the same as adding the exponents. But notice that the base, that's the number below the exponent, has to be the same. If this is not the same number, that's why they use the same letter a here, if it's not the same number, then this property doesn't hold. But if these bases are the same, we can use this property. Let's take a look at some examples. So in the first example here, it says to simplify b to the 9 times b to the 8. Well, these bases are the same, right? They're both b. So what does the property say? It says that we can add the exponents. And so the answer here is b to the 9 plus 8, which simplifies to b to the 17. Okay, let's take a look at the next one. 4 to the 2x, 4 to the x. Okay, well, the bases are the same. So we can use the product property, right? So we add the exponents. So this is going to equal 4 to the 2x plus x. And of course, we can simplify that to 4 to the 3x. All right. And then finally, let's take a look at this one over here. Okay, well, we got some other muck in the way here. Now remember that all these things are being multiplied. This dot means multiply, but also the 3 is being multiplied here and the 4 is being multiplied. So we know that multiplication is commutative and associative. So we can move this 3 and this 4 out front, right? And then we can leave the p's off to the right. Furthermore, any number is the same as that number raised to the first power. So I can put a power 1 up here. All right, now let's simplify things. Well, 3 times 4 is 12. P to the 5 times p to the 1. Well, these have the same bases, so I add the exponents. And simplifying, we see that's 12p to the 6. Okay, cool. Let's move along. Okay, the next property is the quotient property for exponents. So it says that if a is a real number, non-zero, and m and n are integers, then we have these two properties. Now what's important to note with these two properties is in the first one, m is greater than n. The numerator exponent is bigger than the denominator exponent. In the second example, n is greater than m. The denominator exponent is bigger than the numerator exponent. So those are the two cases we have to keep track of. All right, so let's look at some examples. So if we look at this first one, x to the 17 over x to the 5. Well, let's see, the numerator, okay, first of all, the bases are the same. So let's just make sure that's true. Yes, they're both the same thing, x. And the numerator exponent is bigger than the denominator exponent. So we are in this case, m is greater than n. And so this says that this simplifies to x to the 17 minus 5, which we can simplify further as just x to the 12. All right, great. Let's look at this next one. Well, I'm going to write this down again because we have to simplify this numerical part. Okay, so let's do that. Let's simplify the numerical part here. Well, the numerator and denominator, I'm going to divide them by the largest number possible to simplify. And the largest number they're both divisible by is 4. So when I divide, I get this. Now let's deal with the variable part. Well, here's a case where the denominator exponent is bigger than the numerator exponent. So that's the second case when n is greater than m. So what does it say to do? Well, it says that the a moves to the denominator and we subtract 7 minus 3. Let's simplify that. And there we have it. There's the answer. Okay, the last one. Let's write this over again so that we can simplify things more directly. Okay. So let's do the numerical part. Well, what's the largest number these are both divisible by? 3. So let's divide them by 3. Okay. Now let's look at the x part. Here the denominator is bigger than the numerator. That's the second part. N is greater than m. So I'm going to leave the x's in the denominator and subtract 6 minus 5. All right, and then for the y's, remember when we don't see an exponent, that's the same thing as having an exponent of 1. And we see that the numerator exponent's bigger than the denominator. So there we are in the first case, m is greater than n, and so we leave it in the numerator and subtract 8 minus 1. And we'll simplify. Notice 6 minus 5 is 1. We don't typically write the 1. We usually just leave it off. Next up, we have the zero exponent property. It says that if a is a non-zero number, then a to the 0 equals 1. So in other words, any non-zero number raised to the 0 power is just 1. So let's take a look at these examples. So 8 to the 0. Well, 8 is a non-zero number, so when we raise it to the 0 power, we get 1. That's the answer. Look at this one, 6x to the 0. Well, notice that 6 is not being raised to the 0, only x is. So remember in these problems, we always assume the variable is non-zero. So this is a non-zero number raised to the 0 power. So that's 1. So that means that this thing is equal to 6 times 1. So it's equal to 6. Now, I want to write down one more. I just thought of something that might be useful to distinguish. Suppose we had a third problem here, and I wrote 6x to the 0 power. Well, now this is different, right? If x is a non-zero number, then this whole thing is non-zero. And so this whole thing would just be 1. Notice the difference, right? Here, only x is being raised to the 0 power. Here, 6x is being raised to the 0 power. The parentheses make a big difference. Next up, we have properties of negative exponents. This one says that if n is an integer and a is a non-zero number, then a to the negative n is equal to 1 over a to the positive n. Or vice versa, 1 over a to the negative n is equal to a to the positive n. So let's see how we can use this. Okay, so here we have a variable, which we're assuming to be non-zero, raised to a power, right? Now it's a negative 3, so we can use this first part, and we see that we can write that as 1 over z to the positive 3. And that's the answer. Now let's look at this next one here. Well, here we have a negative 5 in the denominator. Well, that's the second part of this problem. It says that we can make that a positive 5, see negative n becomes n, if we take it out of the denominator. We move it to the numerator, so that's what we're going to do. So this is going to be the same as 2t to the positive 5 over 1. So I moved the t from the denominator to the numerator, and of course, dividing by 1 does nothing at all, so I can write my final answer in this form. Okay, let's look at one more example. We're asked to simplify this expression here, a lot more going on. But let's take it one step at a time, and we'll see what we can do here. So let's see. Well, when I multiply, I can multiply, because multiplication is associative and commutative, I can rearrange terms. So I can put the 2 and the 9 together. 2 times 9 is 18, right? I can group the m's together, so I have m to the 6, m to the minus 7, and I can group the n's together, n to the minus 2, n to the 4. Okay? Now, what did we learn in some of the previous properties? Well, we know that when we multiply like this, we add the exponents, right? So let's do that. And again, we can add the exponents here. Okay, now let's simplify things. Okay, so this looks pretty good, except when we simplify, we always like to have the final answer not have any negative exponents. So we're going to do one more step, and that's where we use the properties of the negative exponents. If I want to make a negative exponent positive, I can use this property to do that, right? So I can write m to the negative 1 as 1 over m to the 1. So let's bring this up here. Okay, and now let's just combine everything together. And there we have the final answer. Okay, the next up we have a quotient to a negative power property. So we have a quotient, division, raised to a negative exponent, right? What do? We reciprocate. A over b becomes b over a, and we can change the sign of the exponent. So changing the sign of the exponent, we can do that by reciprocating the fraction on the inside. So let's see how these work out. So this one, 3/5 to the negative 2, well, according to that property, this is the same thing as 5/3 to the positive 2. Now, how do we deal with this? Well, what is a number squared? Well, that is 5/3 times 5/3. Well, 5/3 times 5/3 is 5 times 5 over 3 times 3. And we're done. Okay, let's look at this one. Here we have x over y to the negative 5. Well, that's the same thing as y over x to the positive 5. And we can do more here. We know that raising something to the 5th power is just multiplying it by itself 5 times. Okay, so I got 5 y's, that's y to the 5th, and I got 5 x's, that's x to the 5th. So I could write it like this. Next up, we have the power property for exponents. Notice what we can do here. If we have something raised to a power, and then that whole thing is raised to a power, we just multiply the powers. That's simple enough. Let's take a look at some examples. So we have c raised to a power. That whole thing is raised to a power. So this power property for exponents says that we can just multiply the powers together. So this is c to the 6 times 3, and that's c to the 18. Okay, let's look at this next one. Okay, well, we got something raised to a power and that raised to a power. So again, we multiply the exponents. So that's x squared. That's x to the 2 times negative 3. I didn't mean to write this parentheses over here. All right, and then the next one is x to the 7 times 2. Okay. Well, what's this? It's x to the negative 6 times x to the 14. Just multiplying these numbers together. Now what can we do? Well, remember we had that property a while ago. It says if we multiply the same base with different exponents, we add the exponents. So this is x to the negative 6 plus 14. And that is, of course, x to the 8. Okay, next up we have the product to a power property for exponents. Here we have a product of two things raised to a power. And this says that that's each thing raised to that power. So in other words, the power distributes across products. Let's take a look at some examples. So let's look at this first one. We have a product of three things, -2 times x times y. So this property says the power distributes across the product. So this is going to be -2 cubed x cubed y cubed. All right. Now, what's -2 cubed? Well, it's -2 times -2 times -2. Well, -2 times -2 is 4. 4 times -2 is -8. All right. All right, next up we have this guy over here. Let's see, we had a product, 5 times x to the -3, so we distribute this exponent across the product. So this is going to become 5 to the -2 and x to the -3 to the -2. Notice I put parentheses here so that I know that I'm not subtracting -3 minus 2, I'm raising that to a power. The parentheses are important. All right, well, how can I deal with this? Well, remember we had a property before about negative exponents. We said that that's the same as 1 over 5 squared. The previous property said if we have something raised to a power and that's raised to a power, we multiply the exponents. So that's -3 times -2. Okay, let's see what we get here. Well, that's 1 over 25, right? 5 squared is 25. And -3 times -2 is 6. And just in the final writing this down, I'm going to write it like this. Okay, next up, we have quotient to a power property for exponents. Here we have a quotient raised to a power. What does it say to do here? Well, it says that we can just raise the numerator and the denominator individually to the power. So in other words, the power distributes across division. Very similar to the last property, where the power distributed across multiplication. Well, here it's distributing across division. So it shouldn't be too much of a surprise to you. Okay, well, let's see what we would do here. Well, okay, we got a quotient raised to a power, so we're going to distribute that power across. So this is going to become 2 to the 4 over x to the 4. We can simplify this a little bit because I know 2 to the 4 is 2 times 2 times 2 times 2, and that is 16. Now let's take a look at this one. All right, well, what does it say? It says we distribute the exponent across the quotient. So I'm going to put the 2 on the numerator and put the 2 on the denominator. Notice I'm using parentheses. Those are very important. If I don't use those, it'll look like I'm only squaring the y, but I should be squaring the entire numerator. And that's why I need parentheses around the numerator. Okay, so what can we do next? Well, now we can use some of those other properties. Well, in the denominator, we have something to a power to a power. We know we multiply the exponents. So for the denominator, that's going to be z to the 3 times 2. Now, for the numerator, we have a product raised to a power. So from the previous property, we know that power distributes across the product. Okay, now let's see what we can do here. Well, 3 squared is 9. 2 squared squared. Well, here we have something raised to a power raised to a power. One of the previous properties we saw says that is we multiply the exponents here. So that's x to the 2 times 2, that's x to the 4. And z to the 3 times 2 is z to the 6. And so there's our final answer. All right, so this is just a review of all the properties that we saw. So when you encounter a problem, what you're going to want to do is see which property applies. So we're going to be looking through and seeing if in our problem what we have is one of these things on the left, right? And if we do, then we can apply that property and reduce it to the thing on the right. And you may have to do this several times. But if you keep doing this, you'll eventually simplify your problem.